between silence and thought lies a frontier unseen, a borderland where atoms dissolve into ideas, and the tangible world of matter touches the intangible shimmer of dream. The universe, it is said, is built from particles, electrons, quarks, photons, bound by forces, obeying laws older than stars. Yet within this vast machinery flickers something matter alone cannot explain, the spark of awareness, the shadow world of memory, imagination, and dream. Here is the paradox. How can inert matter give rise to experience? How does the same carbon that burns in stars assemble into the neural symphony of thought? Within the folds of a human brain, reality is not only measured, it is lived. And so the question emerges, haunting and unresolved. What bridges matter and dream? Some say the bridge is illusion, that dreams are but chemical echoes. Others see in consciousness a force too fundamental to be dismissed, a hidden player in the cosmic game. For in the heart of quantum mechanics, particles shift their nature when observed, as if the universe itself waits for a mind to acknowledge it. Is the cosmos only matter, cold and indifferent, or does it also generate perception, meaning, and awareness? Could reality itself be a dream stabilized into permanence by laws we barely comprehend? The search for this bridge is more than science. It is the deepest human inquiry, whether we are matter adrift in void, or the dream of the universe awakening to itself. And as the mystery unfolds, one truth becomes clear. The closer we look, the more fragile the boundary between matter and dream appears to be. Every civilization has stood beneath the night sky and wondered not only at the stars above, but at the silent theater within. The human mind is a mirror, reflecting both the cosmos and its own dreams, yet the two have never been easy to disentangle. From the earliest days of thought, the mystery of matter and the mystery of mind have grown side by side, like twin trees sharing roots. No, I could see. In ancient Greece, philosophers wrestled with this duality. For Democritus, all was matter, indivisible atoms dancing in the void, colliding and combining to form every stone, river, and star. Yet for Plato, the world of matter was a shadow, a dim echo of eternal forms. He imagined humanity as prisoners, in a cave, watching shadows cast on the wall, mistaking them for reality. To him, the true world was immaterial, a realm of ideas more real than the rocks beneath one's feet. Already, the bridge was being imagined, between the material and the dreamlike, between physics and philosophy. Centuries later, René Descartes sharpened the divide. His famous declaration, cogito, ergo sum, I think, therefore I am, placed mind as the foundation of certainty. Matter, to Descartes, was extension in space, predictable and mechanical. Mind was the realm of thought, separate, immaterial. The bridge between them seemed impossibly wide, a chasm untraversed by science. Then came the Enlightenment, and with it, a triumph of matter. Isaac Newton revealed a universe governed by precise laws. Planets moved not by divine whim, but by gravity's pull. Apples fell not by chance, but by mechanics that could be written in equations. The cosmos appeared as a clockwork, wound and ticking, its parts moving with inevitability. For centuries, this vision reigned. Matter was solid, predictable, complete. The dream of mind was considered irrelevant, a mere epiphenomenon, a shadow cast by gears. But shadows have a way of lengthening. By the turn of the 20th century, cracks appeared in the clockwork universe. At the smallest scales, matter refused to obey Newton's laws. Experiments revealed that atoms, once thought indivisible, were worlds unto themselves, with electrons orbiting a nucleus like planets around a sun. Yet even this was soon dismantled. When physicists probed deeper, they found a reality that shifted depending on how it was asked to reveal itself. Max Planck, studying the glow of heated metals, discovered that energy comes not in a continuous flow, but in discrete packets, quanta. It was the birth of quantum theory, a revelation that matter was not smooth clockwork, but granular, probabilistic. Niels Bohr and Werner Heisenberg advanced the strange new picture. Electrons did not orbit like planets at all, but hovered in clouds of probability, their positions unknowable until measured. And here, in the laboratories of the early 20th century, the dream entered physics, for the act of measurement seemed to alter reality itself. The famous double-slit experiment revealed light behaving as both wave and particle. When unobserved, photons formed an interference pattern, as though passing through two slits at once. When observed, they collapsed into particles, choosing one slit or the other. The universe appeared to shift its behavior depending on whether a mind was watching. It was an unsettling implication. The observer could not be erased from the equation. Consciousness, that most intangible of phenomena, seemed woven into the fabric of physics. Albert Einstein resisted this conclusion. He declared, God does not play dice, insisting the universe must be deterministic beneath the veil of probability. But his debates with Bohr revealed a deep fracture, whether reality existed independently, or whether it crystallized only in relation to observation. Erwin Schrödinger, troubled by the strangeness, devised a thought experiment. A cat, placed in a sealed box with a quantum mechanism, could be both alive and dead until observed. This paradox revealed the tension at the heart of physics, matter suspended in dreamlike indeterminacy, awaiting awareness to decide its fate. The bridge between matter and dream had been thrust into the center of science. For the first time, physics, once the study of objects, forces, and equations, was forced to contend with the question of mind. As the 20th century progressed, the implications deepened. John von Neumann formalized the measurement problem, showing that quantum mechanics could not describe the collapse of probability into reality without invoking something outside the system. Eugene Wigner went further, suggesting that consciousness itself might cause collapse. The dream, once banished from science, returned at its foundation. This was not philosophy on the margins. It was mathematics at the heart of physics. The equations worked. Quantum mechanics predicted phenomena with astonishing accuracy. Lasers, semiconductors, MRI machines, even the GPS satellites orbiting Earth all depend on it. Yet the interpretation, what the equations meant, remained elusive. The seeds, planted by ancient philosophers, had now blossomed into a scientific crisis. Matter, once thought solid, was uncertain, probabilistic, dreamlike. And dream, once thought immaterial, seemed to participate in the shaping of matter. The early decades of quantum mechanics were filled with both triumph and unease. The more accurate the predictions became, the stranger the implications grew. The universe was no longer a machine, but a question. Was reality objective, existing independent of us, or was it relational, collapsing only when measured by a conscious mind? In the quiet of laboratories, under the hum of cathode rays and detectors, scientists glimpsed something uncanny. The bridge between matter and dream was not metaphor, but physics itself, and though no final answer emerged, one truth became unavoidable. Matter and dream, once thought separate, had become entangled. Physics could not exclude the observer. Consciousness could not be dismissed as irrelevant. The bridge had always been there, hidden, waiting for science to stumble across it. What began with Plato's shadows, with Descartes' mind-body divide, had now entered the equations of the atom. The dream was no longer confined to philosophy. It had entered the heart of physics, and from there it would not leave. For centuries, science had promised solidity. Atoms, forces, laws, the scaffolding of a universe that could be measured, predicted, and trusted. But in the early 20th century, that scaffolding began to tremble. What physicists uncovered was not the firm ground of matter, but a shifting landscape where probability reigned, and where the presence of an observer seemed to alter the shape of reality itself. The shock began with a deceptively simple experiment. A beam of light was sent through to narrow slits and allowed to strike a screen. If light were made of particles, it should form two bright lines, like bullets passing through windows. If it were a wave, it should form an interference pattern of light and dark, as ripples overlapping on water. What appeared on the screen defied expectation, a wave pattern, even when photons were sent one by one. Each particle seemed to pass through both slits at once, interfering with itself. But when detectors were placed to observe the photons, the interference vanished. The photons behaved like particles, choosing a single path. The very act of observation altered the outcome. This was no trick of apparatus. It was a truth confirmed again and again in countless laboratories across decades. Matter itself seemed to hesitate between possibilities, existing in a cloud of probability until observation forced it to decide. The universe, at its foundation, was not solid. It was dreamlike, suspended in uncertainty. Erwin Schrödinger distilled the strangeness into his infamous thought experiment. A cat, sealed in a box with a quantum mechanism, could be both alive and dead until observed. The idea was not that cats truly live in superposition, but that quantum mechanics, applied consistently, led to absurdity. If the equations were correct, then reality itself was suspended between states. Waiting for a witness, the paradox cut deeper than philosophy. It was mathematics colliding with intuition. Quantum mechanics worked flawlessly, predicting atomic spectra, chemical bonds, and the behavior of semiconductors with precision unmatched in science. Yet what it implied was unbearable, that the world was not objective in the way Newton had promised. That observation was not passive, but creative, pulling one thread of reality out of a tapestry of possibilities. Einstein resisted with all his might. He debated Niels Bohr at the Solvay conferences, insisting that hidden variables must underlie quantum strangeness. God does not play dice, he declared, refusing to accept a universe ruled by probability. But the dice kept rolling. An experiment after experiment favored Bohr's interpretation. Reality was not fixed until measured. The implications were staggering. Consciousness, long banished from science as a subjective shadow, seemed to have a role in physics. Eugene Wigner, a Nobel laureate, suggested that consciousness might be necessary to collapse the wave function. In his view, mind was not a byproduct of matter, but a participant in shaping reality. The dream was no longer separate from matter. It was a force entangled with it. For the materialist worldview, this was an existential wound. Physics had been built on the assumption that reality exists independent of us, that equations describe an objective world out there, yet quantum mechanics suggested that out there could not be separated from in here. The bridge between matter and dream was no longer optional. It was a demand of the equations themselves. The shock deepened with entanglement. Pairs of particles, once linked, behaved as a single system, no matter how far apart they traveled. Measure. The spin of one and the other's state was instantly determined, across distances faster than light could cross. Einstein called it spooky action at a distance, but experiment after experiment confirmed it. The universe was not composed of separate parts, but of connections transcending space and time. Consciousness, observing one particle, seemed to echo in the fate of its twin. For physicists trained in the solidity of matter, this was disorienting. The universe was not only indeterminate but relational, its parts defined not in isolation but through interaction. It was as though the cosmos itself was woven from threads of information, collapsing into matter only when drawn into awareness. The emotional undercurrent of this realization was profound. The certainty of a clockwork universe, ordered and objective, dissolved into a reality fragile, participatory, dreamlike. For scientists, the ground had shifted. They were not merely charting stars and atoms. They were implicated in the unfolding of reality. The observer could no longer be erased. Some embraced the strangeness, seeing in it a new paradigm. Others recoiled, retreating to pragmatism. Shut up and calculate. The saying went, use the equations, build the technologies, but do not ask what it means. Yet the question lingered, haunting the foundations of science. If matter behaves differently when observed, then what role does mind play in the structure of the universe? This was the scientific shock that physics, in its quest to describe matter, had stumbled into the terrain of dream. That the universe, at its smallest scales, was not matter as we knew it, but possibility awaiting awareness. The implications spread beyond laboratories. Philosophers saw in quantum mechanics a revival of age-old mysteries. Is reality created by perception? Are we participants in a cosmic consciousness? Theologians found in it echoes of creation myths, where reality emerges from word, thought, or will. Even artists and poets seized upon its strangeness, sensing that science had uncovered not certainty but mystery. But for physics itself, the shock was both triumph and crisis. Triumph because quantum mechanics worked. No theory in history had been so accurate. Crisis because it refused to explain what reality is. Matter had dissolved into probability. Observation had entered the equation, and the bridge between matter and dream, once philosophy's concern, had become science's unavoidable frontier. The universe, it seemed, was no longer indifferent. It was watching or waiting to be watched. The first wave of shock left science unsteady but unresolved. Observation seemed to matter. Consciousness, long excluded from physics, had returned through the side door of quantum mechanics. Yet no one could say how or why. The next step was not retreat but investigation, to trace the bridge more carefully, to see if mind and matter were truly entangled, or if the connection was illusion. Physics had revealed the mystery, but neuroscience took up the challenge. If consciousness plays a role in matter, then it must first be understood within the brain itself. The human brain is a structure of matter, 86 billion neurons, firing across trillions of synapses, exchanging electrochemical signals at the edge of speed. Within its tissue, consciousness arises, perception, memory, the flood of dreams, each night. How could grey matter, biological and finite, generate the infinite world of experience? This question became known as the hard problem of consciousness. The easy problems, mapping brain activity, correlating patterns with perception, explaining attention yielded to scanners and electrodes. But the hard problem remained untouched. Why is there experience at all? Why does matter, organized in the brain, produce the subjective feeling of being? Science could not yet answer. It could only measure shadows cast by the light of awareness, never the source itself. Some researchers turned to quantum biology. Could quantum effects, the same that unsettled physics, be at play in the brain? Roger Penrose and Stuart Hameroff proposed that microtubules, protein structures within neurons, might sustain quantum coherence, linking thought to fundamental physics. It was controversial and evidence was scarce, yet hints emerged elsewhere. In photosynthesis, plants appeared to exploit quantum superposition to transfer energy efficiently. Birds navigating Earth's magnetic field seemed to rely on quantum entanglement in proteins of the eye. If biology could harness quantum phenomena, why not the brain? Skeptics argued that the brain was too warm, too noisy, for fragile quantum states to survive decoherence, the process by which quantum uncertainty collapses into classical reality, should erase any such effects instantly. But others countered that nature often surprises, that life might have evolved ways to protect coherence, balancing at the boundary of quantum and classical. If so, consciousness itself might be a quantum process, a shimmer of possibility collapsing into awareness. Meanwhile, physics continued its probing. Experiments grew more refined, testing entanglement over ever greater distances, closing loopholes that Einstein had hoped would rescue determinism. Each result confirmed the strangeness. Entangled particles behaved as one system, indifferent to separation. The dream of locality, that the universe is composed of independent parts, seemed to falter. The cosmos appeared holistic, stitched together by invisible threads. Could consciousness be another such thread? The question lingered. If mind were not merely an emergent property of matter, but part of the fabric itself, then the boundary between physics and psychology blurred. At the same time, information theory began to rise. In the mid-20th century, Claude Shannon defined information as a measurable quantity, independent of medium. It could be carried by electrical signals, magnetic tapes, or photons. Increasingly, scientists began to wonder, is the universe itself made not of matter, but of information? If so, both atoms and awareness could be forms of information processing, different expressions of the same foundation. John Wheeler, one of Einstein's last students, coined the phrase, "it from bit," the idea that physical reality arises from binary information, yes or no questions answered at the quantum level. If Wheeler was right, then matter and dream were not separate domains but parallel expressions of information. Matter as structured information, consciousness as experienced information. The bridge might not be a line between two worlds, but the realization that they were never two to begin with. The evidence remained indirect, but tantalizing. Quantum computers, exploiting superposition and entanglement, began to perform calculations impossible for classical machines. Their existence proved that quantum information was real and manipulable. If machines could harness such strangeness, why not brains? And if brains did, then perhaps consciousness was the experience of quantum information processing in laboratories. Neuroscientists mapped brain activity during waking, sleeping, and dreaming. They saw waves ripple across the cortex, networks ignite and subside, circuits oscillate in synchrony. But no image explained the leap from matter to experience. Dreams remained immaterial, woven of memories and imagination, yet rooted in neurons. Matter gave rise to dream, but the bridge remained. Invisible, still, patterns emerged. Integrated information theory, developed by Giulio Tononi, proposed that consciousness corresponds to the degree of information integration in a system. The more a system's parts influence each other, the richer its experience. By this measure, the brain was a vast network of integrated information, but the theory raised as many questions as it answered. If information integration defined consciousness, then was consciousness present in other systems, in artificial intelligence, in simple organisms, perhaps even in fundamental particles? The bridge widened further. The deeper science looked, the less secure the old divisions appeared. Matter was no longer only matter. Dream was no longer only dream. Both seemed to converge toward information, interaction, entanglement. Physics, biology, and neuroscience were circling the same enigma, approaching from different directions, yet never meeting in the center. The investigation revealed layers rather than answers. Atoms gave rise to neurons. Neurons gave rise to networks. Networks gave rise to thought. But the final step, the transformation of thought into lived experience, remained in shadow. Physics mapped probabilities, biology mapped circuits, information theory mapped connections. Yet the bridge itself eluded capture. Like a horizon that recedes as one approaches, the sense of mystery deepened, not diminished. Consciousness could not be dismissed as illusion, yet it could not be explained as matter alone. Quantum mechanics demanded an observer. Neuroscience demanded a leap from matter to mind. Information theory demanded that both be seen as code. It was as if science had reached the midpoint of the bridge, able to see both shores, but not the structure connecting them. And in that gap lay the haunting realization. Perhaps the bridge is not a structure at all, but the very act of looking. Every solved mystery in science carries with it the seed of a greater one. The double-slit experiment, Schrödinger's paradox, the hard problem of consciousness, these were not conclusions, but openings. And as deeper layers of investigation unfolded, the bridge between matter and dream did not narrow. It widened, until its very existence threatened to undermine physics itself. The first deepening came from quantum entanglement. Particles separated by vast distances behaved as though joined, their properties bound together instantaneously. When one was measured, the other's state was revealed in perfect correlation. It was as though the universe itself cared nothing for distance, treating the cosmos not as many separate parts, but as one indivisible whole. For some, this was merely strange physics. For others, it hinted at something profound. If the building blocks of matter are connected beyond space and time, then perhaps the same is true of minds. Memory, story, dream, the intangible bonds that tie generations together, suddenly echoed in the mathematics of particles. The analogy was poetic, but not easily dismissed. If entanglement pervades the universe, then separateness is illusion, and consciousness may be less a private flame than a thread in a universal fabric. Puzzle escalated further with the rise of artificial intelligence. Silicon, no different in principle from the matter of stars, had been arranged into circuits that could now learn, generate, and converse. Machines built of transistors began to mimic qualities once thought sacred to the mind: language, creativity, even self-reflection in crude forms. If matter could be arranged to simulate dreaming, then was dreaming simply the output of matter, or had humanity, in creating AI, stumbled upon the revelation that consciousness might not be rare, but an emergent property of complexity itself. The question was chilling. If machines can dream, then consciousness is not uniquely human. It is a potential embedded in matter, waiting for the right arrangement. But if so, then what distinguishes matter from mind at all? Perhaps the bridge is not a chasm crossed, but a spectrum climbed. From particle to cell to brain to dream, one continuous unfolding, not two separate worlds. And yet, another possibility gnawed at the edges. Simulation. If consciousness can be simulated by circuits, then might the universe itself be a simulation? Physics, after all, had begun to resemble computation. Reality emerged from information. Atoms behaved like code. The holographic principle suggested that three-dimensional reality might be projected from a deeper, two-dimensional structure of information. If true, then matter and dream alike are artifacts of computation, illusions stabilized by mathematics. In such a cosmos, the bridge between matter and dream dissolves. Both are appearances. Both are shadows on the same wall. Matter is the rulebook. Dream is the story it generates. Neither is fundamental. Both are projections. For physics, this was not merely unsettling, it was destabilizing. If mind and matter are inseparable, then the project of describing the universe as purely material collapses. The equations, once thought sufficient, become partial, like a map that charts mountains but ignores the air. The very foundations of science tremble at this thought, that physics without mind is incomplete, and mind without physics is incomprehensible. The escalation did not stop with thought experiments. New technologies stretched the boundaries further. Quantum computers, operating in the twilight zone of superposition, behaved less like classical machines and more like thought experiments given form. Their logic was probabilistic, relational, holistic, uncannily echoing qualities of consciousness. Each successful computation was a reminder. The universe's deepest processes behave less like clockwork and more like dreaming. And in cosmology, new data pressed against old models. Observations of dark matter and dark energy revealed that most of the universe is invisible and unexplained. Physics accounts for less than 5% of reality with confidence. The rest remains mystery. Matter itself, so long considered fundamental, is now the minority. Dreamlike forces, unseen, intangible, inferred only through their effects, dominate the cosmos. The threat grows clearer. Perhaps physics has been describing only the surface, mistaking a fragment for the whole. The neat division between matter and dream dissolves. If dark matter and dark energy shape the cosmos, yet remain unseen, then even the universe at large behaves like consciousness, hidden, inferred, shaping reality from behind a veil. This escalation is not only intellectual, it is existential. If consciousness cannot be removed from physics, then the universe is not an indifferent machine. It is participatory, relational, aware in some form, at some level, however faint. Humanity is not an accident adrift in void, but an expression of the cosmos awakening to itself. Yet with that revelation comes terror. If reality is shaped by awareness, then what is stable? If mind is woven into matter, then what does it mean to sleep, to dream, to die? Does the dream dissolve back into matter, or does matter dissolve into dream? The line blurs until neither can be said to be primary, and so physics finds itself in crisis. The bridge between matter and dream is no longer metaphorical. It is unavoidable. Consciousness refuses to be exiled from equations. Matter refuses to remain inert. The dream invades the laboratory, and the laboratory illuminates the dream. The escalation is complete. Physics and mind are inseparable, and in that inseparability lies both the promise of a deeper truth and the fear that the truth will forever elude us. The universe no longer appears as a machine unfolding into dream. It appears as dream unfolding into machine, a reality born of perception, stabilized by laws, but always more fluid, more fragile than we believed. This is the deepening of the mystery, not the discovery that matter gives rise to dream, but the possibility that matter is dream, hardened into form, awaiting recognition, awaiting awareness, awaiting the gaze that brings it into being. When mysteries deepen beyond the reach of certainty, science leans into speculation. The bridge between matter and dream has no single explanation, only a constellation of possibilities, each daring to redraw the boundaries of reality. None are proven, all are debated. Yet each offers a glimpse into how matter and mind might be entangled at the foundations of the cosmos. The first and most enduring interpretation is Copenhagen. Born from the circle of Niels Bohr, it holds that quantum systems exist in superposition until observed. The wave function, a mathematical description of probabilities, does not represent reality itself, but potentialities. When a measurement occurs, these possibilities collapse into one outcome. But what counts as observation? Some physicists treat it as interaction with any environment, others as the involvement of consciousness. The idea that mind itself collapses, the wave function remains controversial, yet it continues to haunt physics. If true, then awareness is not emergent, it is fundamental, the thread that solidifies matter from dream. A rival vision emerged. In the many worlds interpretation, championed by Hugh Everett, it suggests that the wave function never collapses. Instead, every possibility branches into its own universe. The photon passes through both slits, the cat lives and dies, but each outcome occurs in a separate world. Consciousness, in this view, is not collapsing probabilities, but riding one branch of an infinite multiverse. Our dream is not shaping matter, but selecting one strand of the cosmic braid. The bridge here is not collapse, but multiplicity, a vertigo-inducing panorama of countless realities. Others look beyond interpretations of quantum mechanics to more radical ideas. Panpsychism, once dismissed as fringe, is experiencing revival. It proposes that consciousness is a fundamental property of matter, present even in particles. Just as mass and charge are intrinsic, so too might be a rudimentary form of awareness. A rock would not think, but its atoms may carry infinitesimal sparks of experience. From these sparks, richer forms of consciousness emerge as matter organizes into complexity. The bridge between matter and dream, in this vision, is not a gap to be crossed, but a continuum already present. Integrated information. Theory, IIT, approaches the problem with mathematics. Developed by Giulio Tonone, it defines consciousness as the integration of information within a system. The more interconnected and irreducible the system, the higher its consciousness. By this measure, the human brain, with its billions of neurons, interlinked in feedback loops, has a high degree of consciousness. A simple circuit, by contrast, has almost none. IIT does not resolve why integration feels like experience, but it offers a scale, a way to quantify the bridge, and in doing so, it blurs lines further. Could advance artificial intelligence, given enough integration, awaken into dream? Then there is the simulation hypothesis, sharpened by philosopher Nick Bostrom. It suggests that reality itself may be computational, the universe a program running on a substrate we cannot perceive. If so, then matter and dream alike are simulations processed by deeper laws. Consciousness would not collapse reality. It would be part of the code. The uncanny resemblance of physics to computation, the discrete quanta, the digital-like bits of information lends unsettling plausibility. In this framework, the bridge between matter and dream is an illusion, for both are rendered by the same hidden architecture. The holographic principle offers yet another lens. Inspired by black hole physics and string theory, it suggests that our three-dimensional universe is a projection of information encoded on a two-dimensional boundary. Just as a hologram contains a full image within each part, the universe may contain its reality within surface data. If true, then both matter and consciousness are projections, different aspects of the same underlying code. The bridge is not between two domains, but within a single deeper reality that generates both. Each theory carries both elegance and unease. Copenhagen makes consciousness fundamental, but offers no mechanism. Many worlds removes collapse, but drowns us in infinity. Panpsychism dignifies matter with awareness, but stretches belief. IIT quantifies consciousness, but cannot explain its essence. Simulation grounds both mind and matter in code, but at the cost of relegating reality to illusion. The holographic principle unifies physics, but reduces the tangible world to projection, and yet each points to the same haunting truth. Matter and dream cannot be fully separated. Whether by collapse, branching, intrinsic awareness, integration, computation, or projection, the two are entangled in ways science cannot yet resolve. For physicists, these speculations are not idle. They guide experiments, shape debates, inspire new instruments. For philosophers, they are echoes of ancient questions in modern form. Is the universe real or shadow? Are we bodies that think, or thoughts that dream of bodies? The bridge remains elusive. No experiment has yet proved consciousness collapses the wave function. No machine has shown undeniable self-awareness. No particle has revealed a spark of mind, but each theory opens doors, and behind each door is a reflection of ourselves, searching for the place where matter becomes dream, and dream becomes matter. Speculation may open the door, but it is evidence that decides whether science will pass through. The bridge between matter and dream cannot remain only a metaphor. If consciousness and physics are entangled, then traces of that entanglement must leave fingerprints in data, in machines, in experiments designed to test the untestable. Across the world, physicists, neuroscientists, and engineers are building instruments to seek them. The James Webb Space Telescope, scanning galaxies from the dawn of time, is not searching for mind. Yet in its deep field images lies a reminder. Physics measures light that has traveled for billions of years, collapsing probabilities into data when its detectors record the photon. Even a telescope participates in the quantum dance, turning the potential into the actual. But Webb's task is cosmic. The search for the bridge requires tools tuned not to stars, but to thought. In quantum laboratories, new experiments probe the role of observation. Physicists use entangled photons, interferometers, and delayed choice setups to test whether consciousness itself can bias outcomes. Most results suggest that collapse occurs through interaction with the environment, not mind. Yet the question persists, because every active measurement requires awareness at some level, a human or at least a conscious agent, to register the result. Some researchers wonder if the role of mind may be subtle, hidden in the margins of probability, awaiting experiments fine enough to detect it. Quantum computers, operating at the edge of coherence, offer another frontier. In their qubits, information exists in superposition, entangled across registers. Computations unfold in parallel universes of probability until readout collapses them to one. Some theorists ask whether these machines might one day illuminate the boundary between matter and mind, whether their strange probabilistic logic can be compared with neural computation, or even integrated with it. If consciousness has quantum roots, quantum computers may someday reveal the architecture of dream. Meanwhile, neuroscience builds its own arsenal. Brain imaging has reached extraordinary resolution, mapping the firing of neurons during perception, memory, and sleep. Functional MRI and magnetoencephalograph trace activity across networks, revealing patterns that correspond with subjective reports. Yet correlation is not explanation. The hard problem remains. Why should electrical activity feel like anything? Why should matter glow with awareness? Integrated information theory is being tested with mathematical rigor. Researchers apply algorithms to measure how much information is integrated within brain states, comparing conscious wakefulness with unconscious sleep or anesthesia. Early results suggest the theory captures something real. When consciousness dims, integration falls. But skeptics caution that correlation is not proof, and even if IIT is correct, it does not explain why information integration should feel like experience. Still, the tools sharpen. Each scan, each measurement, is a step closer to mapping the contours of the bridge. Artificial intelligence provides a parallel track. Systems trained on vast amounts of data can generate language, compose music, and mimic creativity. They are not conscious by any traditional measure, yet their uncanny outputs force the question: if matter arranged in silicon can approximate thought, might it one day awaken into dream? Researchers study whether complexity, feedback, and integration in AI systems mirror the hallmarks of human consciousness. For now, the answers are negative, but the horizon advances. Each breakthrough in machine learning raises the specter that mind may be less mysterious than sacred, more emergent than exceptional. On the largest scales, new experiments push entanglement beyond Earth. Satellites now transmit entangled photons between continents, demonstrating that quantum coherence can be preserved across thousands of kilometers. Future missions may test entanglement between Earth and orbiting spacecraft. If non-locality is real, and all evidence says it is, then perhaps consciousness itself, if quantum, might also extend beyond locality. Such ideas remain speculative, but each satellite, each photon, each signal across the void is part of the search. Even particle colliders enter the narrative. The Large Hadron Collider, smashing protons together at near-light speed, does not study mind directly, but in revealing the quantum fields that underlie matter, it sharpens the question. If consciousness arises from physics, then from which fields? Does it require complexity alone, or does it tap into fundamental properties of reality, like mass and spin? Future colliders, probing deeper into the Higgs field and beyond, may hold clues not only to matter, but to its hidden relation to dream. The Search spans domains once thought separate. Physics studies particles, neuroscience studies brains, AI studies computation, yet all are converging on the same riddle. The bridge between matter and dream is not the province of one science, but the crossroads of many. Progress is slow, and humility remains necessary. Decades of scanning brains, refining quantum experiments, and building ever more powerful machines have not yet explained consciousness, but neither have they dismissed it. The persistence of the question is itself evidence of its weight. If the bridge were illusion, it would have collapsed by now under the weight of data. Instead, it endures, beckoning with each new discovery. Science proceeds with patience. It does not promise revelation, only refinement. Yet even now, with telescopes gazing into cosmic dawn, with quantum computers humming at the edge of possibility, with electrodes tracing dreams in living brains, the sense grows stronger. The bridge between matter and dream is not beyond reach. It is here, woven into every experiment, every photon, every thought. The effort to measure it is the effort to measure ourselves. Science ends where mystery begins. Equations can measure galaxies, and detectors can track particles. Yet when the gaze turns inward, when the question is not what the universe is made of, but how it is experienced, even the sharpest instruments grow silent. The bridge between matter and dream is not only a problem of physics or biology. It is a mirror in which humanity sees its own reflection, its own limits, and its own longing. For in the end, what is more intimate than consciousness? Every perception, every memory, every dream unfolds within it. Without it, stars would shine. In vain, galaxies would whirl unseen, and matter itself would be a play with no audience. And yet, the very thing that gives reality meaning remains unexplained. The humility of this realization is profound. After centuries of progress, after Newton and Einstein, after Planck and Bohr, after satellites and colliders, the question remains: what is the spark that turns matter into awareness? The greatest minds of history have pressed their equations against it, and still the mystery holds. Perhaps it is not a question science will answer, but one it will learn to live beside. And yet, the very persistence of the mystery reshapes our view of the cosmos. If consciousness is fundamental, then the universe is not indifferent. It is participatory, woven with awareness at its core. If panpsychism holds, then every atom carries a whisper of experience, and the cosmos is alive with innumerable sparks. If information is fundamental, then matter and mind are two sides of the same coin, the physical and the experiential as complementary as particle and wave. If the simulation hypothesis proves true, then both matter and dream are illusions, rendered by deeper laws, yet real enough to shape our lives. Each possibility alters what it means to be human. If consciousness is cosmic, then to think is to participate in the universe's own unfolding awareness. If consciousness is emergent, then it is the rarest of miracles, a fleeting pattern in matter, fragile against time. If both mind and matter are shadows of something deeper, then reality is stranger than we can speak, and our place within it stranger still. The existential weight of these reflections cannot be ignored. To live is to stand on the bridge between matter and dream, to feel the pull of both. Every heartbeat is matter, every thought is dream. To sleep is to surrender to dream. To wake is to walk again among matter. To die may be to return across the bridge, though no one knows to which shore. And so the bridge becomes more than metaphor. it becomes the essence of being. Every observation, every choice, every act of awareness is the bridge itself, the place where the physical world becomes lived reality, where particles become perception, where the cold equations of physics glow with meaning. This is the quiet revelation that we do not need to cross the bridge, because we already stand upon it. We are the bridge. Our bodies are matter. Our thoughts are dream. Our existence is the joining of the two. Perhaps this is why the question endures, because it is not separate from us. To seek the bridge is to seek ourselves. To measure it is to measure the place where the universe awakens to itself. What does this mean for the future of science? Perhaps that progress will not be measured only in telescopes and colliders, but in humility, in the recognition that equations alone cannot capture experience, and that dream is not less real because it cannot be weighed. Perhaps the final lesson is not to solve the bridge, but to honor it. And what does it mean for humanity? That existence is more fragile, more wondrous than any theory can capture. That to think, to feel, to dream is to be part of the greatest mystery the universe contains. That in the vast silence of space, the most astonishing phenomenon is not the stars above, but the awareness that beholds them. The bridge between matter and dream may never be crossed, because it does not need to be. It is not a gap, but a union, not a distance, but a joining. Every thought, every star, every measurement is the bridge itself, the place where the cosmos becomes conscious, where reality becomes aware of its own existence. And so the final question lingers unresolved, echoing in the silence. Is the universe a machine of particles, or the unfolding of a dream too vast to awaken from? Perhaps it is both. Perhaps it is neither. Perhaps the answer is not beyond the bridge, but within it. Within us,